Okay, this time let's have the formulas of arithmetic series. Okay, in arithmetic series, there are two formulas. The first formula, which is the one introduced by Carl Friedrich Gauss, the formula is S of n is equal to n over 2 times a sub 1 plus n over 2. This is the first formula, where your n here is the number of terms. Your a sub 1 here is your first term, and your a sub n is the last term. So in the second formula is derived from the first formula. So the second formula is S of n is equal to n over 2 times 2 a sub 1 plus quantity n minus 1 times d. This formula was derived from the first formula. I will not explain to you further. Okay, so where n here is the number of terms, a sub 1 is the first term, d is the common difference, s is the sum of the series or the sequence. So we have s of n here is the sum. Also here s sub n is the sum. So in here, in the first formula, please take note for this. You can use this one if the last term is given. The second formula is to be used when there is no last term. So, in the sequence, if there is no last term, then we can use this formula. If the last term in the first term is given, then we can use directly this formula. So, for instance, 33, 46, 55, 64, 73, and 82. So we are going to find the sum of this arithmetic sequence. So that means the sum that refers to arithmetic series. Now, so we need the terms to be added, the first term and the last term. The last term is 82. So we can use the first formula. In the given sequence 33, 46, 55, 64, 73, 82, there is a last term. So we can use the first formula. Okay? So we need to use the first formula. So let's write out first the given. What is n? How many terms are to be added? 1, 2, 3, 4, 5, 6. So n is equal to 6. A sub 1 is equal to a sub 1, that is your first term, which is 33. What is your a sub n? What is your last term? Last term is your a sub n is your last term, so that is 82. So since you have all the three unknowns now, I mean the given n, a sub 1, and a sub n, so we can now get the sum of this arithmetic series. N over 2 times a sub 1 plus a sub n. Okay, so substitute s, n is 6, s sub 6, 6 over 2 times a sub 1, which is 33, plus a sub n, that is 82. So 6 divided by 2, that is 3. 33 plus 82, that is 115. 3 times 115, that is 345. So the sum of the terms from 33 to 82 is 345. You can check your calculator if that is really 345 by adding 33 plus 46 plus 55 plus 64 plus 73 plus 82. So let's have the next example. Find the sum of the first 10 terms of the sequence 5, 10, 15, and so on. So, in finding the sum, we need n, which is 10, because first 10 terms. There are 10 terms to be added. So, here, the first term is 5, right? And there is no last term here. But we need to add 10 terms, so we don't know that last term. So that is why we will be applying the second formula. So we need n, which is 10, a sub 1, which is 5, n, which is 10, and d, which is also 5. So from 5 to 10, that's plus 5. From 10 to 15, that's plus 5. So the common difference is 5. So if you have already these three given, then we can now solve, or we can now get the sum of the first 10 terms of the sequence that starts from 5, 10, 15, and so on using the second formula. So the second formula is S of n equals n over 2 times 2 times a sub 1 plus quantity n minus 1 times d. Let's substitute. S of 10 means sum of 10 terms is equal to 10 over 2 times 2, this is always 2, a sub 1, which is 5, times 5 plus n is 10. 10 minus 1 times your d is 5. So S of 10 is equal to 10 divided by 2, that is 5, times 2 times 5, that is 10, plus 10 times 1, that is 9, times 5, that is 45. So 5 plus times 10 plus 45, that is 55. So 55 times 25, that is 110. Therefore, the sum of the first 10 terms of an arithmetic sequence that starts from 5, 10 to 15 and so on to the 10 terms of the sequence is 110. Okay, let's try this next example. Find the sum of 3 plus 5 plus 7 plus 9 plus ... plus 57. Now, which do you think of the two formulas is to be used? A sub 1, which is 3, and the last term, which is 57. That means the first formula is applicable here. But now, in the first formula, so we need to find how many numbers are to be added. That is n. So how do we solve for n? So in order to solve for the sum of the series here, we need to have all the three given. But take note, we cannot easily identify n here, or the number of terms to be added. So by that, you're going to use first the arithmetic sequence formula to find for your n, because n is unknown. So here, so your a sub n is equal to a sub 1 plus quantity n minus 1 times d. So you have to use first the arithmetic sequence formula in order to find n. Okay? So, for you to get the sum of the sequence or the series, so let's substitute. So, here, what is a sub n? That is 57. Right? What is your first term? That is 3 plus, since there is no n, just copy n, minus 1. Your d here is, what is your d? It's 2, positive 2. When you go to 3, when you go to 5, that's plus 2. When you go to 7, plus 2, plus 2, and so on. So d is 2. So, copy 57 equals 3 plus, distribute 2. 2 times n, that is 2n. 2 times negative 1, that is negative 2. Okay? So, 57 equals 3 minus, combine like terms, 3 and negative 2. So, 3 minus 2, that is 1. So, 2n, 3 minus 2, that is 1. Now, our goal here is to find n. So, we need to isolate 2n here. So, transpose positive 1 to the other side. So 57, you transpose 1, so that becomes negative 1. From positive becomes negative. And what left here is 2n. Okay? So what is 57 minus 1? That is 56 equals 2n. Divided by 2. Divided by 2. So n is equal to 28. So there are 28 terms to be added. So if you already know how many terms are to be added, so you can now get the series of the sequence. So by substituting, s of 28 is equal to 28 over 2 times a sub 1, which is 3, plus a sub n, which is your last term, which is 57. 28 divided by 2, that is 14. Then what is 3 plus 56? 57, that is 60. So what is 14 times 60? That is 840. Therefore, the sum of the terms from 357 until 57 is 840. Again, if there is no n, you need to use first the arithmetic sequence formula to find n, and after that, decide which of the two formulas is applicable in getting the arithmetic series. Again, the first formula is to be used when there is last term, while the second formula is to be used when there is no last term. Okay, let's try this next example, number 3. It is still a sigma notation. It asks you to find the sum. Here, again, the number here is where you start, and the number above the sigma notation is where you end. That means you will start from 8th term until 50th term. You will add all those numbers from 8 terms to 50th terms. And this is the formula. Now, it's hard for you to find the sequence. Instead of doing that, you will just use the formula of arithmetic series. So, again, the formula is s sub n is equal to n over 2 times a sub 1 plus a sub 2. Okay, again, we need all the three given unknowns. The unknowns. And a sub 1 and the a sub 2. Let's try to find the first term. The first term is a sub 1. Now, copy the formula, which is 3 plus 2n. So, in finding n, in finding the first term, so copy 3 plus 2, what number is to be substituted by n? So that is 8, because this is the starting point, and this is the ending point. So 8 will be substituted by n. N will be substituted by 8 rather. So 8. 3 plus, what is 2 times 8? That is 16. 3 plus 16, that is 19. So the first term of the sequence is 19. Now we're done with the first term. Let's proceed to the last term. So the last term is of n is equal to 3 plus 2n equals 3 plus 2. What number will be substituted by n? That is 50, because it is the ending term. That is 50 equals 3 plus, we just copy 3 plus, what is 2 times 50? That is 100. 100 plus 3, that is 103. So that means your last term is 103. Okay, so far so good. Again, we need the first term, the last term, and the n. How do we solve for n? Now, it's hard for you to count because there are many numbers here. From 8th term to 50th term. Gikan sa 8th term hangtod sa ika-50 nga term, pila daw kuno silang tanan i-add. So, mag-ihapkin tayo ka. 8, 9, 10, 11, 12, until 50, which takes time. So, all you need to do, this is the formula in finding n. Take note for this. 50 minus, now, if we will do 50 minus 8, that's 42. But do you think there are 42 numbers to be added? Are there only 42 numbers to be added? No, because we will include 8 terms. So 50 minus, instead of 8, we will subtract 8 by 1. Okay? We will subtract 8 by 1, so that becomes 7. So 50 minus 7 is 43. So therefore, there are 43 numbers to be added in all, and that is your n. So n is equal to 43. You can check that starting from 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 until you reach the 50th term, and that is, the total number is 43. Because you start counting from 8, not from 9. Understood? So there are 43 numbers to be added from 8 to 50. So your n is 43. So you have all the three unknowns, n, first term, and the last term. So you can now get the sum of the arithmetic series using the formula. So let's solve the sum by substituting the formula. N is 43. Again, the sum of 43 terms, n equals 43 over 2 times a sub 1 is 90 plus a sub n, the last term is 103, equals 43 divided by 2 times 19 plus 103, that is 122. Okay? 43 divided by 2, you can have it in decimal form, the one that we did a while ago. So 43 divided by 2 is 21.5. times 122. Anyway, it will give you the same answer. 21.5 times 122, that is 2,600. This is the sum of 43 terms starting from 19 until